Step 3 of urine formation is tubular secretion. So tubular secretion is the reverse of reabsorption, and it's of very select substances. So here we can see the peritubular capillary and substances getting put back into the tubules to be excreted from the body. And that's what tubular secretion is. So most of it occurs in the proximal convoluted tubule, and some of it occurs in the collecting ducts as well. And why we need tubular secretion as a kind of a refining step at the end of urine formation is because when we're disposing of substances, like it says here, like some drugs or some metabolites, some of these things are bound to plasma proteins. And remember, our plasma proteins are stuck in the blood. They can't get filtrated or filtered into the tubules because they're too large, and they continue along in the blood in these peritubular capillaries. So we need a mechanism to detach some of these substances, like drugs, metabolites, from their plasma proteins, and then pump it into the kidney tubules. So it's a fine-tuning step to get rid of some of these metabolites and drugs in our system. Also, tubular secretion, it's a step to get rid of waste products. Urea, uric acid, these are waste products in our blood that need to be eliminated. When this material collects in our blood, it becomes toxic. So this would need to be filtered out as part of the urine. So the urea and uric acid was in the filtrate originally from glomerular filtration, but remember that tubular reabsorption, some of it is a passive process. So some of the waste products, some of the urea and uric acid actually gets reabsorbed back into the blood because it just naturally follows a concentration gradient and goes there. So in tubular secretion, this is a special step to put it back into the tubules where it was originally in step 1. It got removed back to the blood in step 2. Now we put it back into the tubules in step 3. So we're eliminating those undesirable waste products right here that were passively reabsorbed in step 2. So in step 3, we secrete it back into the tubules for elimination. Also, we're getting rid of excess potassium ions, the aldosterone effect. You might recall, I'll go to a picture here, with aldosterone, when we were talking about tubular reabsorption in blue here, aldosterone, let me use an arrow, there we go, aldosterone puts sodium ions into the blood, so water will follow to increase your blood pressure, but with sodium leaving the tubule, potassium takes its place, and that's kind of a driving force. Potassium entering will cause the sodium to leave. You see it here too. Regulated secretion of potassium ions by aldosterone. So when we're looking at this step here, ridding the body of excess potassium, because that aldosterone effect will reintroduce this potassium back into the tubule in exchange for the sodium being kept or reabsorbed into the blood. And the final point here, this we'll look at next chapter, but it's part of tubular secretion, so we're going to mention it here, but kind of put it on the back shelf until chapter 26, but controlling our blood pH. So we can alter the amounts of the hydrogen ions. Remember, more hydrogen ion, more acidic the blood is, or the bicarbonate ion in the urine. So by playing with these two ions through tubular secretion, that can help control, or will control, the pH level in the blood. So here's our summary with tubular secretion step 3 in green. You see that some of the drugs will re-enter the kidney tubules at the proximal convoluted tubule. We also have our waste products like uric acid or urea that will enter or be secreted back into the kidney tubules that were passively reabsorbed in in step 2. And then there's our aldosterone effect, putting potassium back into the kidney tubules. So there were your 3 steps in 3 different videos of urine formation, 1, 2, and 3, and we're going to kind of go into some detail on some of the processes occurring during urine formation in the upcoming videos.